Hi, it's Professor Muldrow once again. First thing we're going to look at in this video is characters, using individual characters from a string. One method you should be aware of is this char@at method. The char@at method is able to get an individual character from a string, but to use it, you have to send the index of the character you want as a parameter. So as you can see in the slide here, if my string variable whose name is food is set equal to cookie, if I do food.char@0, that gets me the first character of the string, because all strings, the index of the first character is always 0. Char values can be compared with pretty much any comparison operator. Here you have ASCII values. Now, unlike a string though, a char variable is a primitive type. So you cannot call methods from a char variable like you can from a string variable. Unfortunately, we have a character class that is built into Java. This character class contains, among others, these methods that you see right here. For example, the isDigit will tell you if the character is a digit, a number. IsLetter means is it the letter? Is it lowercase? Is it uppercase? And we can convert a character to lowercase and to uppercase by using the character class in this way. Now over here in this code, what I'm asking the user to do is type a sentence, and I use this line right here to read that statement with the next line method and then convert it to all uppercase. Then in this for loop, what I'm going to do is look at each individual character by using the char@at method to get each individual character. I'm using the for loop's variable x as the parameter. And first I say if it's a letter, okay, now let's see if it's a vowel or a consonant. So if it's A, E, I, O, or U, I add 1 to the vowel variable. Otherwise, I add 1 to the consonant variable. If I get to this else, now I see if the character is a digit, if it's a number. If that's the case, add 1 to the number variable. And if it's anything else, add 1 to the other variable. And then I output how many of each one I got. So let me run this one and see what happens. So now I'm asked to type a sentence. I'll make it brief. Welcome to 2023. And I'm told this sentence contains 4 vowels, 5 consonants, 4 numbers, and 3 other characters. The 4 numbers is pretty obvious. 4 vowels, there's an E, an O, an E, and another O. And then as far as the other characters, remember, a blank space is part of a string. That counts as a character. So a blank space, there's 2 blank spaces and an exclamation point. That makes 3. So there you have the use of the character class. Give me just a moment, I'll show you something else. Let's do it right now. Another thing we can do in C++ is formatted output. If you want to do formatted output, you must use the system.out.printf for format command. Now, what you see here on this slide is a way to display integers in a field. So for example, I have printf %4d. The percent symbol tells the compiler, oh, this is how we're going to format things. The D tells it it's integers, and the 4 tells it how many characters total displayed. So like, for example, this number 1 down here in the slide, that's 1 digit, that's 1 character. But I'm supposed to have a field width of 4 characters. So we're going to put 3 blank spaces before the 1. And that makes 4 characters. Similarly for the 2, 3 blank spaces before the 2. Now, once you get down to 2 digits, like for the 10, we'll put 2 blank spaces in front of the 10. So 2 blank spaces, then a 1 and a 0. There's your 4 characters. Most commonly, we use formatting to round to decimal places. So that's where you use the %.f, f for floating point. So here we have a GPA variable set to this value. The first printf says your GPA is %.1f. Now, percent just means there's formatting coming. F means it's floating point, meaning it has a decimal point. If a number comes after the dot when %f is used, that means round to this many decimal places. Since we have a .1, that means we're going to round the value of GPA to 1 decimal place. And as you can see in the first output, your GPA is 3.3. 3.25 rounds to 3.3. In the second one, where it says more precisely, notice we have a number before and after the dot. Well, the 3 after the dot means that you round to 3 decimal places. The 8 before the dot means you must have 8 total characters when you display this. So, for example, if we round this value to 3 decimal places, that is 3.254. Now, the decimal point counts as a character. So therefore, we have 1, 2, 3, 4, 5 characters within this new GPA. But we have an 8 in front of the dot. That means we need a field width of 8 characters. Okay, we already have 5 right there. So that means you must add 3 blank spaces before 3.254. And there are your 8 characters when rounding to 3 decimal places. So when using %f, the number before the dot is the field width. That's how many characters total will be displayed. The number after the dot is how many decimal places we're going to round to. And in this example, in this code, I'm asking the user to input a radius. And I use it to calculate the area of a circle and the volume of a sphere. Notice here in the code, I'm using printf. And for the area and the volume, I'm saying %10.3f. I'm doing that for both. So that means I'm going to display this in a total of 10 characters. And I'm also going to round to 3 decimal places. In fact, I'm going to get rid of that space before the equal sign just to make it obvious what's going on. Okay, let us first clear the output. And let's run part 2. Okay, and our value for the radius there, I put a 10. Now, as you can see, it says area 10.3. My area came up 314.159. That's 1, 2, 3, 4, 5, 6, 7 characters. That means I put 3 blank spaces before the value for the area. Same thing for the volume. 1, 2, 3, 4, 5, 6, 7, 8 characters displayed here. So that means I put 2 blank spaces before the value for the volume because they both have a width of 10 characters. Now, if I were to put a minus sign in front of one of these, like let's put a minus sign in front of the 10.3 for the area. If I run that, input my radius, look what happens to the area. If you put a minus sign in front, that means it's left justified. That's why now the 314.159 is right against the equal sign, and the 3 blank spaces come after to make it a 10 character field. So that's what the minus sign can do. Okay. Finally, we're going to use some new methods on strings. If you try to compare the value of 2 strings like this, we say name, which is a string variable, is equal to Barney. It'll compile, but it won't work right. Since name is a string variable, so it's an object of a class, you can't compare values in this way. But remember, since a string is a class and we create objects of a class, you can call methods from that object. We actually have an equals method for strings. They'll determine if the variable name is indeed equal to Barney, is exactly the same. And that returns a true or false. Other methods you can use on a string are equals. There's the one we've seen. Equals ignore case. There's a very important one. That will compare 2 strings, but it won't matter if like they're the same word, but one's uppercase or one's lowercase. Equals ignore case will return true as long as it's the same word. Equals would not return true in that case because everything has to match. Every single character has to match exactly. Starts with gives you back a true or false if the string starts with whatever's in the parentheses, ends with, and then contains. Contains means whatever's in the parentheses is somewhere in the string. So showing you part 3, here I've declared 2 strings called this and dat. I know, real creative. This is set to Telemundo, and dat is also set to Telemundo, but notice how dat is different. We use a few more capital letters in dat than we do in this. So here I'm saying if this equals Telemundo in all capitals, and here I'm saying if dat equals ignore case Telemundo. Let's run that and see what we get. Lo and behold, we get, for the first one, for this equals Telemundo, we get lo siento, no es lo mismo, which is Spanish for I'm sorry, it is not the same. For the equals method, we're comparing this, which is Telemundo with only a capital T, to Telemundo with all caps. Not the same. But on the second one, equals ignore case, we get C, es lo mismo. Yes, it is the same. Because equals ignore case doesn't care who's uppercase and lowercase, it's able to figure out, is it the same word? That's why we get C, es lo mismo for that. Now, ends with and starts with, they have to be exact matches. So if I say dis ends with mundo, I get C, it is. If I say dat starts with tele, but notice here in the starts with, I have a lowercase L, but in dat, I have an uppercase L. That's why I get a no. And there you have other things to do with strings and formatted output and characters. If you have any questions, please send me an email at kmuldrow@lbcc.edu.